Hey, this is a video for 7.7, Acid Rain. So go ahead and check out the overview and set up your guided notes. So right now I'm going to give you a brief overview, which is also a review because we all know how fondly you look back on your chemistry days. The pH scale is a logarithmic scale. It is the concentration of the H plus ions in a solution. And it's on a scale of 0 to 14, as indicated by these numbers, but this really means 10 to the 0, 10 to the minus 1, 10 to the minus 2, 10 to the minus 3. So this is 1.0, 0.1, 0.01, 0.001. In other words, what that means, if you are asked a question like how many more times hydrogen or hydronium ions are present in a sample of lemon than in a sample of bananas. So we're comparing lemons to bananas. We have pH of 2 and a pH of 5. So notice the concentration is 10 to the minus 2 and 10 to the minus 5. So what we want to do is we want to indicate both of these on the pH scale. And we want to figure out for every jump we do between 10 to the minus 5 and 10 to the minus 4, that's a factor of 10. This is a factor of 100. And this is a factor of 1,000. So lemons have 1,000 times more H plus ions than a sample of bananas would. Now, just for reference, normal rainwater is pH of approximately 5.5. So even though we say that 7 is neutral, most solutions in nature tend to be slightly acidic. Now, the regular pH range, at least when I was working in the lab, like our neutral was 6 to 8. But, around 6 is going to be, relatively neutral. Now, when we get into basic conditions, we have sodium bicarbonate or baking soda. We have sodium hydroxide, and we have chlorine bleach. These are all basic solutions. Ammonium is also basic. Now, where does acid rain occur? For starters, it is called acid rain. You will also see it called acid precipitation. In some cases, acid deposition. And that's because there can be solidified acidic particles that are falling back to Earth. For our purposes, we can use interchangeably acid rain and acid precipitation. But if you see acid deposition, don't be freaked out by it. It literally just means the same thing. Now, where is this occurring? It occurs pretty much in the Northeast in the United States anyway. We have a few industrial centers. We have right here, we have the Cleveland area, we have the Detroit area, and we have the Chicago area. All three are major manufacturing areas in the in the Midwest and in the Northeast. The problem is the wind blows from the west. So whenever they have all this manufacturing, they're generating a lot of pollutants. And those pollutants are moving east. And as they move east, you're going to find acid precipitation is going to occur downwind of these sites. So even though Chicago is a major manufacturing hub, a lot of their acid precipitation is happening over the Great Lakes. Now, how does it occur? So you have emissions from factories, predominantly coal-fired power plants that are releasing sulfur dioxide into the atmosphere. You will also have fossil fuel combustion through internal combustion engines. They are releasing sulfur dioxides and nitrogen dioxide into the atmosphere. Now, when that reacts with rain, what happens is you will get sulfuric acid and nitric acid. You should really commit these to memory. SO2 becomes H2SO4. If you can't remember the H2SO4, at least remember sulfuric acid and nitric acid. That might help you to earn points. There might be questions about the chemistry. I cannot guarantee that. Now, when they fall back to Earth, they're not falling back as regular rain. They're falling back as acidified rain, which can be very damaging to agricultural crops, to plants, to human structures as well. Some of the effects is we can have corrosion, especially if we have limestone statues. If you notice, a lot of the old statues from like Greek and Roman times are corroded, and that is because of years and years of acid precipitation. And remember that even regular rainfall is slightly acidic. That's because it's interacting with carbon dioxide in the atmosphere. Another effect is you can have acidification of various ecosystems, whether it is acidification of the soil or acidification of aquatic ecosystems. One thing to pay attention to is for an organism like a frog, amphibians are very sensitive. They're great indicator species because they can tell us how healthy an ecosystem may be. Frogs predominantly will live at least part of their life in the water. So they need to, anything that's in the water is going to be interacting with their skin. It's also going to be entering their body. So frogs have a relatively normal or narrow range of tolerance. But when the precipitation, when you get acid precipitation and the waterway might be slightly acidified, this frog's going to be outside of its range of tolerance. And acidification could be detrimental to the survival of many frog species. Now, in the soil, it's a little bit trickier. You should understand this chemistry. So recall that soil is made up of 3 different particles. We have clay, we have silt, and we have sand. Clay is the smallest of the 3, and clay particles are negatively charged. That's what all of these represent. They kind of have like this kind of, even though they're really, really small, but they kind of have this like little sheet-like structure to them. Now, normal soils are between 5.5 and 7.5 pH. And these clay particles within a normal soil will attract all of these wonderfully positively charged ions. Some of these ions are beneficial, like potassium, like sodium, like calcium. Some of these ions are not beneficial, like chromium, like aluminum. The water, when it rains, the water is polar, recall that. So it's very difficult for the water to pull these away from the clay particles. Pull these ions away from the clay particles. However, when it is acidified, when the rainwater is acidified, we're going to have more hydrogen ions present. And what's going to happen, if you think of a little short person trying to get to the front of a line, they kind of can push their way through under the crowd. That's kind of what happens here. These hydrogen ions are pushing their way in, and they are bumping out these aluminum ions. So now the hydrogen ions are being held tightly to the clay particle because they were delivered by the rain droplets. Now these aluminum ions will be water soluble, and they will very likely enter a plant because the plants will take them up through their roots, and that can be cytotoxic to the plant tissue. So it will stop the plant from growing. The plant will be entering some physiological stress. The plant will definitely be outside of its range of tolerance. Now, the other thing that can happen if you have acidified soil is these hydrogen ions can take the place of these healthy ions, these nutrients that plants so desperately need. So if the soil is highly acidified, these hydrogen ions will bind to the clay particles and push out these beneficial ions like potassium, sodium, and calcium. And they will be water soluble, and they will wash away with the excess runoff. Now, one way of mitigating this, mitigation is a word that shows up kind of regularly. Mitigation really just means damage control. It's minimizing the impact from an environmental stressor. So one way that we can mitigate the effects of acid rain, if we have acidified soil, maybe the soil is at a pH of like 4.5, for example, we can add calcium carbonate, also known as limestone, also known as lime. We can add lime to the soil, and that can push the pH back up to a more neutral pH. Recall that soils that are formed with bedrock from limestone are going to be more basic and less acidic. So they're going to be more beneficial for agriculture. Now, you've seen the word mitigation. If you ever see the word remediation, remediation means removing the threat when possible. It's sort of like prevention. Okay, I hope that this gave you a lot of information. Hope that some of it was a review from Chemistry Days. Please respond to this check for understanding. And for our FRQ practice, explain how acid precipitation can impact soil's nutrient exchange capacity. I hope that this video is informative. I thank you for your attention, and I will see you soon.